Welcome to our deep dive on intrusion detection and prevention systems. Over the next 65 slides, we will explore the technology, deployment strategies, and best practices for protecting your enterprise network from sophisticated threats. This video provides a complete roadmap for IDPS. We will cover core concepts, detection methods, open-source tools like Snort and Suricata, cloud-based solutions, and how to effectively tune your systems to reduce false positives and block malicious traffic. An intrusion detection system, or IDS, is a passive monitoring tool. It acts like a security camera, identifying unauthorized access or malicious activity on your network and alerting security teams, but it does not block the traffic itself. In contrast, an intrusion prevention system, or IPS, is an active, inline security solution. It acts like a security guard, not only identifying threats but also taking real-time action, such as dropping malicious packets or resetting connections to stop an attack. While IDS operates passively and is easier to deploy with no impact on network performance, IPS works inline to provide immediate threat prevention. This requires careful tuning to ensure legitimate traffic isn't accidentally blocked. Firewalls are not enough on their own. IDPS systems provide essential deep packet inspection, visibility into lateral movement, and the audit trails required for compliance, significantly reducing the average time to detect a breach. The 2024 statistics are clear. Breaches are costly and often take months to identify without proper tools. A human element is involved in 68% of cases, highlighting the need for robust, automated detection capabilities. The history of IDPS spans over 4 decades, evolving from academic research by James Anderson and Dorothy Denning to modern, AI-powered cloud-native solutions that dramatically reduce false positives in high-speed enterprise environments. We categorize these systems into 3 types. Network-based, which monitors traffic at strategic points, host-based, which installs agents on individual servers, and hybrid or distributed systems that correlate data across your entire infrastructure. Network-based IDS sensors connect to taps or mirror ports to capture and analyze traffic. They are excellent for identifying broad threats like port scans, but often struggle with encrypted traffic unless SSL/TLS decryption is deployed. The NIDS pipeline is a multi-step process. Traffic is captured, normalized to prevent evasion, compared against a rule set, and if a match is found, an alert is generated and sent to a management console or SIEM for analysis. Proper sensor placement is critical. Best practice suggests deploying sensors at trust boundaries, such as the network perimeter, DMZ, and internal segments, using dedicated network taps to ensure 100% packet capture. Host-based IDS, or HIDS, uses agents installed directly on your systems. They monitor file integrity, system calls, and application logs, providing deep visibility even into encrypted traffic, though they do consume local system resources. A HIDS is made up of core components: a file integrity monitor to detect unauthorized changes, a log analyzer to identify suspicious patterns, and a system call monitor that inspects low-level OS activity for signs of compromise. Finally, network-based IPS acts as an inline block against threats. It operates at high speeds to drop malicious packets or reset connections in real time, with high availability configurations ensuring your network stays protected and performant. Next, let's look at host-based IPS, or HIPS. This software protects endpoints by intercepting system calls and blocking malicious actions before they can execute. It's effective at stopping buffer overflows, unauthorized registry changes, and process injection techniques. Wireless intrusion detection and prevention systems are designed to secure the wireless layer. They monitor 802.11 traffic for rogue access points, detect evil twin attacks, and can even automatically contain threats by sending deauthentication frames to unauthorized clients. Network Behavior Analysis, or NBA, moves beyond simple signatures. It analyzes traffic patterns and builds baseline models of typical behavior, allowing it to detect deviations that often indicate DDoS attacks, data exfiltration, or command and control activity. Modern IDPS relies on 3 core detection methods: signature-based detection for known threats, anomaly-based detection for unknown attacks, and protocol analysis to ensure traffic adheres to strict standards and prevent protocol-level abuse. Signature-based detection matches traffic against a database of known attack fingerprints. While extremely accurate for identifying known threats with near-zero false positives, it is inherently limited by its inability to detect new zero-day attacks. In practice, these signatures identify specific behaviors, such as SQL injection strings, port scans that exceed defined thresholds, or malware command and control beacons. They are vital for blocking established high-volume threats. Anomaly-based detection uses machine learning to learn what normal network behavior looks like. After a training phase, the system flags significant deviations, such as a workstation unexpectedly sending massive amounts of data in the middle of the night. The primary advantage of anomaly detection is its ability to identify novel, zero-day threats. However, it requires a significant training period and often has a higher false positive rate, making it more complex to tune effectively. Stateful protocol analysis provides deep inspection by validating traffic against RFC standards. It understands the expected sequence of commands for protocols like HTTP or DNS, allowing it to catch evasion techniques that other methods might miss. Most modern systems are hybrid, combining all three methods for defense in depth. Correlation engines integrate alerts from signature, anomaly, and protocol analysis, significantly increasing confidence levels and reducing the noise of false positives. Machine learning is increasingly central to modern IDPS. Techniques like supervised learning for classification and unsupervised clustering for identifying unknown attack groups are transforming how we detect and respond to sophisticated threats automatically. Deep Packet Inspection, or DPI, goes beyond headers to examine the entire packet payload. This allows for fine-grained control, such as identifying applications regardless of port or enforcing content-specific policies, though it requires robust hardware. An effective IDPS architecture comprises three main components: distributed sensors or agents that inspect traffic, a central management server that distributes rules and correlates data, and a console for analysts to view alerts and manage history. Reliable alerting is essential. Systems communicate detections through protocols like syslog or SNMP, while advanced formats like JSON enable seamless integration with SIEM platforms for real-time monitoring, incident response, and forensic packet capture storage. Finally, we must recognize Snort, the world's most widely deployed open-source IDPS. Now maintained by Cisco Talos, its highly efficient multi-threaded architecture and massive community-supported rule set remain a cornerstone of network security today. Let's break down the Snort rule structure. A rule consists of two parts: the header, which defines the action, protocol, and traffic flow, and the options, which contain the specific content, metadata, and stateful detection logic used to flag an event. Practical Snort rules can be incredibly effective. Whether you're detecting ICMP pings, identifying SQL injection attempts via specific payloads, or monitoring for SSH brute force attacks using thresholding, THESA rules provide targeted security across your environment. Suricata is a high-performance, multi-threaded IDPS built for modern, high-speed networks. Since 2009, its ability to utilize multiple CPU cores and its native support for protocol detection have made it a favorite for handling massive throughput. When comparing Suricata and Snort, consider your needs. Suricata excels with its multi-threading and built-in protocol detection for high-performance needs, while Snort offers the largest rule database and is backed by extensive Cisco Talos intelligence. For host-based detection, OSSEC is a leading open-source choice. It provides comprehensive security by performing real-time log analysis, file integrity monitoring, and rootkit detection, while its active response feature can even automatically block attacker IPs at the firewall. Zeek, formerly known as Bro, takes a different approach. Rather than focusing on simple alerts, it logs detailed network activity, creating a rich history of connections, DNS queries, and file transfers that are invaluable for deep forensic investigations. In the commercial space, solutions like Cisco Firepower, Palo Alto Networks, and Fortinet's FortiGate provide robust next-generation IPS capabilities. These platforms integrate advanced threat intelligence and high-speed hardware acceleration to secure large-scale enterprise environments. Other major enterprise players include Checkpoint, Trend Micro Tipping Point, and Trellix. These vendors offer specialized IPS appliances and blades that focus on massive throughput, continuous signature updates, and protection against sophisticated, evolving threats. Your IDPS deployment strategy should begin with a thorough risk assessment. Strategically place sensors at the network perimeter, between internal segments to catch lateral movement, and on critical servers to protect your most valuable data assets. You can deploy in inline or passive mode. Inline mode allows for active blocking but requires high availability, while passive mode provides safer, zero-latency monitoring by receiving a copy of the traffic, making it ideal for forensic analysis. Effective sensor placement is a best practice. Ensure coverage at the internet edge, behind firewalls, and within your core switches and data centers. Don't rely solely on the perimeter. Many modern threats move laterally inside the network. In cloud environments, traditional hardware won't work. You need cloud-native services or virtual appliances that can scale automatically. Technologies like VPC traffic mirroring allow you to extend your detection capabilities into your cloud infrastructure. For AWS, options include the managed AWS Network Firewall, Amazon GuardDuty for threat detection, and WAF for web applications. You can also deploy virtual IDS sensors for deep inspection of mirrored VPC traffic. Microsoft Azure offers robust security through Azure Firewall Premium, which includes built-in signature-based IDPS. Coupled with Microsoft Sentinel for alert correlation and Defender for cloud, you get a powerful, integrated security posture for your Azure workloads. Finally, Google Cloud provides Google Cloud IDS, powered by Palo Alto Networks, alongside Cloud Armor for WAF protections. Together with the Chronicles SIEM, these tools offer comprehensive visibility and threat detection for your Google Cloud native environment.